Okay, for this problem, let's convert this base 16 hexadecimal to 7.8 AF, where the AF is repeating. Let's change this from base 16 into a fraction in ordinary base 10. The way to do this, let's see, so 7.8 AF bar, that means 7.8 AF, 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 and so on. Okay, now this is in base 16, so the 7 just means 7. This means 8 over 16 to the first power. In base 10 it'd be over 10, but now that we're in base 16, this is over 16. The next one, 10 for A over 16 squared. The next term would be F, which is 15 over 16 to the third. And it's third because this first F is in the 0, 1 to third spot. And then 10 over 16 to the fourth, plus 15 over 16 to the fifth, and we go two more terms out, 10 over 16 to the sixth, plus 15 over 16 to the seventh, and so on. Okay, so we have 7 plus a half at the start. And now let me regroup this. So first I've got a bit of terms, I'm going to do this in green, where I have the numerators of 10. 16 squared, then 16 to the fourth, 10 over 16 to the fourth, and then 10 over 16 to the sixth, and so on. Then I have another group of terms, I'll put this in orange, where I have 15s in the numerator. So 15 over 16 to the third, plus 15 over 16 to the fifth, plus 15 over 16 to the seventh, and so on. Okay, so I still have 7 plus a half in front. I'll deal with that later. The terms in green are a geometric series. The first term of the geometric series is 10 over 16 squared. And the common ratio is 16 squared. I multiply by 1 over 16 squared to go from one term to the next term. Then I would multiply this one by 1 over 16 squared to go to the third term, and so on. So the common ratio is 1 over 16 squared. And so using the formula for an infinite geometric series, I have first term A over 1 minus r. And the r is 1 over 16 squared, 1 over 256. And then lastly, the last bit, we have the first term is now 15 over 16 to the third. And the common ratio is once again 1 over 16 squared. Because I multiply this first term by 1 over 16 squared to get 16 to the fifth in the bottom, I multiply this by another 1 over 16 squared to get 16 to the seventh in the bottom. Okay, so let's see. So we have equals 7 plus a half plus 10 over 16 squared, and then it's over 1 over 1 minus 1 over 16 squared is the same as 255 over 16 squared. And then the last term, we have 15 over 16 cubed times 1 over 255 over 16 squared. Okay, now let's simplify this. Clearly 16 squared cancels 16 squared here, and 16 squared cancels 2 of the 16s there. So my common denominator is going to be 16 times 255, and 16 times 255 is 4,080. So I have a common denominator of 4,080. So 7 times 4,080. Then this next bit, 1/2, is the same as 2040 over 4,080. This next bit I've got 10, and then I need to multiply that by 16 to get 16 over 4,080. And then finally the last part is 15. And so finally we get our answer to be 30,775 over 4,080, written in ordinary base 10. And that simplifies by canceling 5s to 6,155 all over 816. And so that is the answer. And the technique was to use infinite geometric series to convert the decimals into fractions.